In this video, I'm going to show you how to solve equations, both polynomial equations like this one, but mostly it'll be about rational equations like this one. So I think we already know how to solve the polynomial equations like this one. We want to get 0 on one side. So that would give us x squared. I'm sorry, it's not x squared. That's going to give us x to the 4th power plus 9x squared minus 10 is equal to 0. This is quadratic form. If the first term is double the degree of the middle term, we can usually factor this like a normal quadratic equation. So x to the 4th power can only factor as x squared and x squared. 10. Could have been 2 times 5, but we're going to go with 1 times 10, right? Based on the middle term being a 9. So 1 and 10. Okay, to get the positive 9 out of it, we need a positive 10 and the negative 1. Can either one of these be factored further, anybody?
Yes.
Yeah, which one are you looking at, obviously? The x squared minus 1, that's the difference of 2 squares. So this can factor further as x plus 1 times x minus 1. X squared plus 10 cannot be factored further. Okay? Now, we get the solutions by setting each one of these equal to 0. So this is going to give me x is equal to negative 1, x is equal to positive 1. What do you think about this one over here, you guys?
None.
None, right? Can you see if I subtract 10 from both sides? You can't square something and get a negative number. That's ridiculous, all right? There's no solutions coming out of this. So negative 1 and positive 1, those are the only 2 solutions to example 1. So the rest of these are going to be rational equations where we have a polynomial in a numerator and in a denominator. Here's the key to the whole thing. You want to get like denominators. And once we have like denominators, we'll be able to cancel those denominators out. That's the key. So on this problem, to get like denominators, I can see that I have a denominator of x plus 3 over here on the left. So I definitely need a denominator of x plus 3 to make them alike. That would be illegal just to stick an x plus 3 underneath there, unless I put x plus 3 in the numerator as well. Now I have like denominators. So listen to me carefully. Once you have like denominators, you're allowed to cross them out. I mean, technically what I'm doing is I'm multiplying both sides by the denominator, like I'm multiplying by x plus 3 and x plus 3, and even I'm multiplying 0 times x plus 3, and that's why I'm canceling them out. But you don't have to show all that. You can just, once you have like denominators, you can cancel them out when you're solving any equation. Okay, so that brings me to the following. So now I have 20 minus 4 times x plus 3 is equal to 0. When you do the distributive property, be careful. This is a negative 4 at this point. Please distribute a negative 4, not just a 4. So this is going to be 20 minus 4x minus 12, okay, not positive 12, is equal to 0. I see some like terms happening right here. So I'm going to have negative 4x plus 8 is equal to 0. You know, I could like do a GCF or something, but using our Algebra 1 skills, we might as well just get x by itself. So negative 4x is equal to negative 8, dividing both sides by negative 4. We get x is equal to positive 2. Okay? It's not happening on this particular problem, but there's one thing that you have to watch out for. Extraneous solutions are possible. When you're solving rational equations, sometimes you'll do everything correctly, but you'll come up with some so-called solutions that don't actually work, usually because there's some sort of a domain issue, like it's an illegal value. For example, if I got x equals -3 for my answer, can you look back at the original equation and tell me why this would not be allowed?
Yeah.
Tell me why. Yeah, that would cause 0 right here if x were -3. So always just look back and make sure that whatever solution you have doesn't cause any issues like that. Okay, it didn't happen on this problem, but sometimes it does. Okay, so example 3. Again, I need like denominators. So I see the denominator of x minus 8. So I definitely need to have an x minus 8 right here. And that will only be legal if I put x minus 8 in the numerator as well. Once I have these like denominators, I can cancel them out. Okay, so that's going to leave me with x times x minus 8 plus 6 is equal to 0. So that's x squared minus 8x plus 6 is equal to 0. Hopefully this is factorable. If it's not factorable, we'll have to use the quadratic formula, which does happen sometimes. So be emotionally prepared. I see some frowns on those faces. But it's not happening yet. Maybe it is about to happen right now. Yeah, this is not going to factor. So quadratic formula it is. Or we could complete the square. Would you rather quadratic formula or completing the square?
I don't know if that's complete the square.
It's when you like move the size over and then you like.
Quadratic Formula.
I'm going to do. You know what? I guess I'll just do both. So we could solve this by. First, I'm going to do this by completing the square, which would actually be my favorite way of doing this particular problem. When I look at the middle, if it's an even number and there's no number in the front, completing the square is actually really easy. It goes like this. First of all, you move that 6 out of the way. So that leaves you with x squared minus 8x, leave a space, and that equals -6. Okay? Then this is going to become, this trinomial, including the missing term, is going to become a binomial squared. The binomial is going to be x minus 4. The 4 comes from being half of 8, okay, half of that middle term. Now, this helps me know what the missing term needs to be. Okay, if I ignored the x there, I would have -4 squared. That would be 16. That's the missing term that completes the square, 16, okay? I'm adding a brand new 16 on the left. That means I need to add 16 on the right to keep the balance. So that's going to give me 10. Okay, now I can solve this equation really easily by taking the square root of both sides. Don't forget your plus or minus. Super important. So that's going to give me x minus 4 is equal to plus or minus radical 10. And then if I add 4 to both sides, then there's your answer. X is equal to 4 plus or minus radical 10. All right? So those are the two answers, solutions to this equation. Now, I could, let me change colors and show you how to solve it using the quadratic formula. All right, so that's completing the square. The quadratic formula, that's the one that goes x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so in this problem, a is 1, b is -8, and c is 6. So this is going to give me opposite of b, so it's 8 plus or minus the square root of b squared, so that's 64, minus 4 times 1 times 6. Okay, all over 2a, which is just 2. So that's going to give me 8 plus or minus 64 minus 24. So that's going to give me x is equal to 8 plus or minus 40 over 2. 40, so that's going to be 2 radical 10, if I simplify it. Okay, now just reducing this, both of these are divisible by 2, so that's going to give me 4 plus or minus radical 10. Okay, so that's how you would solve it using the quadratic formula. So I don't care which way you use, but be advised, if it doesn't factor, you'll have to either complete the square or use the quadratic formula, whichever one's more comfortable to you. Okay, moving on to example 4. Who is squeaking, man? This is looking like it's going to be factorable. Okay, so it's going to be x and x, 2 times 4, minus and minus. Is everybody comfortable with that factorization? Okay, luckily these two match the denominators that I already have. So all I have to do is make sure that each denominator has both things. So this one already has x minus 2, so it just needs x minus 4 next to it. So I'll put x minus 4 in the numerator. This one already has an x minus 4, so it just needs an x minus 2 next to it. I'll put an x minus 2 in the top. Once I have those like denominators, I can cross them out. Okay, so that's going to give me 4 is equal to 3x times x minus 4 plus 2 times x minus 2. So that's going to be 4 is equal to 3x squared minus 12x plus 2x minus 4. Got some like terms here in the middle, so this will be 3x squared minus 10x minus 4. And then if I subtract 4 from both sides, that will give me 0 is equal to 3x squared minus 10x minus 8. Okay, so hopefully this is factorable.
It is negative 12 and 10.
Okay. So let's see, so you can use the star method or whatever method you use. I'm just going to go like this. So 3x squared, that's 3x times x. I'm looking at that 8, and I'm thinking that's either going to be 2 times 4 or 1 times 8. All right, that's all I got. So I'll try the 2 times 4 first and see how that works out. All right, inner, that would make 2x. Outer, that would make 12x. Okay, inner plus outer must equal middle. That's the Burton way. Hold on. Okay, so to get a negative 10 middle, I would need a negative 12 and a positive 2. So that would mean that this would have to be positive and this would have to be negative. I have to check one more thing before I declare victory. I need to make sure I'm really getting negative 8. Positive 2 times negative 4 is negative 8, so boom, done. Okay, so this is the correct factorization. So people who did the star method, did you get the same thing as I did? Jesse, did you get the same thing as me? She's almost done. Okay. Okay, so continuing on to the solutions, we have to set these each equal to 0. So if I set 3x plus 2 equal to 0 and x minus 4 equal to 0. That's going to give me x is equal to negative 2/3 and x is equal to 4. Before I even box these, I'm just going to glance back up at my original problem to make sure that none of these are extraneous. What do you see? Anybody notice anything? Any problems? All right. Look at this 4 right here. Okay. Why is this 4 going to turn out to be extraneous? Right. Look at this factor right here, x minus 4. If x were allowed to be 4, that would make 0. Can't divide by 0. Okay. So this x equals 4, that's extraneous. So do not put that down as one of your solutions on test day. Natanya, so see how we have to look at the x minus 4 that's highlighted?
Yeah.
If x was allowed to equal 4, if you plug that in,
Okay. No, I got you.
okay. All right, so the only solution, the one and only solution is x equals negative 2/3, nothing else. All right, let's do one more. Example 5 here. Okay, again, we need like denominators. Now, I don't have 0 over here, so I need like denominators even on this. So the two factors I see are x minus 2 and 2x plus 1. So I'm going to need both of those. I need x minus 2 and I need 2x plus 1. Okay, x minus 2, 2x plus 1. So there's that. Here I have the x minus 2. It's going to also need 2x plus 1. All right, this one has the 2x plus 1. It's going to need the x minus 2 to go with it. Okay, now I have like denominators. Once you have like denominators, you can cancel out the denominators. Okay, so this is what I have. So now I need to multiply these binomials together. FOIL it, double distribute, whatever you want to call it. So this is going to make, if I multiply this pair together, that's going to give me 2x squared. Okay? And here again, you know how I'm always saying inner plus outer equals middle? I'm doing the same thing right now as I multiply these. I'm going, what's the inner and the outer now? Because that's got to make the middle. I'm still doing that. That's why it matches. That's why I do it that way. So inner, it's 1x. Outer, it's negative 2x. Together, that makes negative 1x. Okay, and then minus 1. So I get that. Again, if I do this pair right here, 3x times x, of course, is 3x squared. Now I'm going to do my inner plus outer again. Inner, I've got 6x. Outer, I've got negative 6x. Right? 6x, negative 6. So those cancel each other out. So 6 times negative 2 is negative 12. Okay. And if I multiply these together, now I have to do it. So if I multiply these together, so I've got x times 2x, so that's 2x squared. Inner, I've got negative 4x. Outer, I've got positive 1x. Negative 4 and positive 1, that's negative 3x. And then negative 2 times 1 is negative 2. Okay, so on the left-hand side, I'm going to combine some like terms here. Right, because I've got the 2x squared and the 3x squared. Those are like terms. And I've got the minus 1 and the minus 12. Those are like terms. So putting those together, I will have 5x squared minus x minus 13 equals. And over here, I need to do the distributive property. So that's going to give me 6x squared minus 9x minus 6. Okay. Now I'm going to put everything on one side of the equation. So I'm going to subtract 5x squared from both sides. All right, I'm doing it in this direction, so I get a positive x squared. I'm going to add x to both sides. And I'm going to add 13 to both sides. All right, so that's going to give me 0 equals x squared minus 8x plus 7. So hopefully this will factor. That'll be really satisfying after all this work. Okay, so I've got x and x. 7 and 1 is the only way to go. All right, they've got to be minus and minus to make negative 8, and it also gives me positive 7. Negative 7 times negative 1 is positive 7. Whew! It means I must have done all that right. So obviously if I set each of these equal to 0, I'm going to get x equals 7 and x equals 1. Are either of these extraneous? No. Okay. Yeah, none of these will cause a 0 denominator. So these are both good. All right, so that's it. So this problem has two solutions. X equals 7 and x equals 1. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.